Inference of proportions. We are going to look at proportions of an outcome in a population or across several populations. A university in the Northeast claims in its brochures that it has an acceptance rate of 60%. A sample of 300 students, high school seniors, who applied to this university shows that 148 of them were accepted. At the 0.05 significance level, test the hypothesis. Test the hypothesis, which means we're going to be doing a hypothesis test. So first, let's start with state. What is it looking for? So with these states, we always want to be very specific. So the proportion of high school seniors accepted to a university in the Northeast. We know this because it says it right here. Okay, so let's find our ho and ha. Ho is basically what they're saying, and what they're saying is that our P equals 0.60. They say that it's 60% acceptance rate, which is why we're putting 0.6. Okay, and our ha is that P does not equal 0.60. Okay, next thing, this is part of our state. Next, we want to plan. In this part, we're saying what kind of problem we're doing. So what we're doing is a z-test. C-test, and the reason it's test is because it's a hypothesis test. Now, in this part, we also want to do the conditions. Let's look at all the conditions. First condition is SRS. We need to know if it's a simple random sample. Let's look at the problem again. It's a university in the Northeast claims its brochures that it has an acceptance rate of 60%. A sample of 300 high school seniors who applied in this university were accepted. So it says a sample, but it does not tell us if it's a random sample, which is why we're going to put proceed with caution. Proceed with caution, because we don't know if it's a random sample or not. Now, our step number 2 is 10%. The population size is at least 10 times greater than the sample size, we know. Now, it says 300 high school seniors. We know that the population has to be, the population is 300. It has to be 10 times greater, which means, let's see, 300 times 10 would be 3,000. Is there more than 3,000 seniors in a high school? We're gonna say that yes, there is. So check on that one. All right, number 3 is NP is greater than 10 and NQ is also greater than 10. So to check this is, what is our N? Our N is 300, that's the sample size. So 300. And P, our P would be 0.6. Now, what is 300 times 0.6? You plug it into your calculator, and the answer would be 180. 180 is definitely greater than 10, so that one's good. Now, NQ, 300. Q is 1 minus P. So since we know P is 0.6, just 1 minus 0.6 would equal 0.4. So let's put that right here. We plug this into the calculator and we end up with 120, which is also greater than 10. So number 3, let's check on that one also. because we got that. And number 4, let's check it. Is it a binomial? Like binomial? And what is binomial? Okay, so B, binomial. What is binomial? Basically, it's the binomial distribution is where there's only 2 outcomes, 2 possible outcomes. So either they got accepted or they didn't. So that's the kind of problem it is. So we're going to put a check on that one. I for independent. Is it independent? Yes, it is independent because each student is independent of whether they got accepted or not. One student didn't affect if the other one got accepted or not. So yes, it is independent. N is fixed. We're gonna say yes because we're saying it's 0.60. That's what they're saying, I mean. So yes, it's fixed, and it's the same for everyone. It's 60% of acceptance rate for every population. And S, the success of the probability stays the same. The probability of success is the same. It's the same for each student. The acceptance rate is the same for each student. It's always going to be 0.60. It doesn't change for each student. It's the same. So now that all our conditions are met, we can start on the do. Okay, so our do. This is where we solve it. The equation, the formula for the hypothesis test is this. Now, we can do this by hand or we can do it by calculator. Let's start with by hand and then we'll show an easier way, which is by calculator. Okay, so our p hat, we need to know what p hat is. The way we know this is to find p hat, the count of successes in a sample and the count of observations in a sample. All right, so the count of successes was how many people got accepted. 148 people got accepted, right? So we would put 148 over 300. Over 300. This is for p hat. P hat. All right. So, and we plug this into the calculator and we end up with 0.493. All right, so let's put that in. Okay, so if we plug it into a calculator, the answer would be negative 3.77. And then we need to find our p. So to find our p, we need a z-graph. Okay, to find our p, to do a significance test, we need to know our p, our probability. And we do that by looking at a z-table. To get the exact number, we can do it in a calculator, and that's what we're going to show you right now. Before we plug everything into a calculator, let's just write down all our variables. So, all right, now let's go into plugging it into the calculator. All right, so basically our calculator tells us that P is 0.0001624 and so on. So what do we do with this now? Basically, if P is greater than alpha, if P is greater than alpha, that means there's insufficient evidence to, to check what our state. If P is less than alpha, that means there is sufficient evidence. So let's do our conclude so you can understand. To conclude, let's put it into words now. Because P is less than alpha, which alpha, let's just say our alpha is 0.5. The reason we know this is because the significance level, that's our alpha, 0.05. That's what we use this for, the significance level. So alpha is the significance level. If our P is less than alpha, that means there's sufficient evidence, and this is what we put. Okay, so our conclusion would be there is sufficient evidence to suggest that the proportion of students accepted into a university in the Northeast is not 60%.